And then in order to get total cost, you copy this, paste it, and shift it exactly $48 up, and you get the total cost. So the difference between these two curves here, this distance, is how much everywhere? 48. Well, Max, your Excel is broken, right? These aren't the same apart everywhere, right? It looks like they're further apart here than they are up there. Well, that turns out to be an optical illusion, right? And I'm totally serious. If you actually take a ruler and you measure the distance between the purple triangle and the blue and yellow, the purple rectangle and the blue and yellow triangle, the distance, no matter where you are, see, same distance, same distance. As the functions get steeper, vertical distances appear to be closer. So we should print what's on your rearview mirror. If you are lucky enough to own a car, objects appear closer together than they truly are. All right? So when you draw this yourself, when you draw these curves by hand, they always come closer together on the right side, visually, even though they're the same distance apart. All right, so that's total cost, total variable cost, total fixed cost. What are we missing? The pain in the neck ones you've never heard about, all right? Marginal cost, average variable cost, and average total cost. Whoa, what just happened? This is horrible looking, Max. Take a design class. Okay, how about, did I bring money today? I've been living off of credit cards forever. Ooh. For one of my 2 last dollars, what color is average fixed cost on here? Raise your hand, right there in that jean jacket. That's right, you just made $1. All right. I pay my kid, too, to do stuff, right? I mean, if the economist doesn't understand that incentives work, who does? So thank you for that correct answer. How did you I'm going to make you work a little bit for that whole dollar. How did you figure it out? Oh, yeah, I love that answer even better, Mac, because it says so right here. You get another $1 for that next time I walk over there. That's, of course, the really smart answer. But if you hadn't looked at the legend here, right, what we said is you start out with a total fixed cost, and then you distribute it over more and more units. So average fixed cost has to be falling everywhere. So the only curve on this whole picture that's really falling everywhere is the pink one. You're spreading out your fixed cost over more and more units of output, so it has to be monotonically falling everywhere. The next ones get tricky. Right? So here there's a lot of stuff going on. Let me point out some new friends to you. Okay? We have marginal cost right here. This is the blue curve, which looks a little bit bumpy, right? But it sort of looks like a weird U shape almost. Here, the black one, that's average variable cost, which looks a little bit like a salad bowl. And green here, that's going to be average total cost, also looks a little bit like a salad bowl. So how are these related? I know that average total cost, the green line, is the vertical sum of average variable cost, which is my black line with the yellow triangles, and average fixed cost right here. Right? So black line plus purple line right here should get you green line. So let's check that. 16 plus 22, 38, right? 6.9 plus 20.1 should be exactly 27. So that's exactly what we get. Average fixed cost plus average variable cost equal average total cost. An easier way to think about it is the distance between average total cost and average variable cost right here, the black line. What's the difference between the two? What's the difference between average fixed cost and average variable cost? You can recycle your answer for another $1 if you want. Just say average fixed cost. There you go. It's exactly average fixed cost, right? So if the sum of the black line and the pink line here is the green line, then the distance between green line and black line is simply the pink line. So the difference between average total cost and average variable cost has to be average fixed costs. Since average fixed costs are dropping everywhere as you increase output, they start really far apart and they grow closer and closer together. So green and black lines start really far apart, but you can see here they start growing closer and closer and closer together. Now something else happens. I should have brought more money. That's always true. What curious thing happens right here and right here? So marginal cost, the blue line, cuts through average total cost, and the marginal cost cuts through average variable cost. Does it cut at a sort of intriguing, interesting point? Who said that? You're my favorite person in the room right now. All right? That's exactly correct. I like all my students equally. But the point here is it cuts at exactly the lowest point, both the average variable cost and the average total cost curve. So why is that, Max? You can feel it already what's going to happen next. You ready for this? To mix things up a little bit, I brought a different color shoelace. This one's orange. All right? They don't make these anymore. This is vintage 1980s. They make them, but just not the way they used to. So what we're going to do is we're going to convince ourselves that this makes sense algebraically, and we can actually calculate these things. And then right after that, now that this shoelace is stopping to be shy, we're going to use this shoelace to actually draw the picture I just showed you qualitatively, so we know how to draw average variable, average total, and marginal cost curves. All right? Why do we do this? I'm going to tell you why. Number one reason is, as we'll see in about a lecture, the firm maximizes profit where market price is equal to marginal cost. So the marginal cost curve is going to become really important because it tells us how much output the firm should be producing in a competitive market. The average variable cost curve is going to matter because if you take in fewer dollars than average variable cost at the optimal level of production, you should shut down production. All right? You're not supposed to understand why that is yet, but I'm just telling you, I'm not just making you draw these curves because the textbook says so, and Perloff is a smart man, but this has huge ramifications for the firm's decision on how much to produce and when to shut down, which is, I think, something we'd want to know about. Right? It also is going to, as we'll see in the long run, relate to interesting things like which countries produce how much cotton relative to other countries and why, and how many profits are they taking home? Why do ag subsidies matter? Anybody here care about ag subsidies? Right here. My arm's hurt. I can't lift my hand any higher right now, but I would. So this stuff is really important. Take my word for it for now, and in about 3 lectures, this will become very, very clear. So let's quickly use an algebra example, which most people don't like, but I do, so we'll do that. And then we'll do the drawing version, which more people like, and I like less, because I have to do it, and it's really hard. So why am I? Hold on. I screwed up here. I'm sorry. Let's ignore this one for a second. Let's do shoelace right away. Now I remember. I moved the algebra example back further because I thought that was better, and that does make sense. So let's briefly worry about how we draw these functions. Okay? The first thing I'm going to draw is a stylized total cost curve. Then I'm going to draw a stylized total fixed cost curve and a stylized total variable cost curve. What I mean by stylized is don't take these units so seriously on the y-axis. So when you stare at this picture later and you try and relate it to something and the numbers don't exactly match up, don't panic. It's just Max is not drawing this to scale. All right. So the thing I like to always start with is total fixed cost. Why do I like to start with that? Because it's a flat line and it's easy to draw. Okay? So let's say fixed costs are $20. That means total fixed costs looks something like this. Horizontal line at $20. Now I'm going to draw my total variable costs. Okay? My total variable costs are going to look something like this. Inverse U, and then regular U. Okay? So there's going to be a little inflection point right here. What are total costs going to look like? They're going to look like this. We're going to add fixed costs to total variable costs and draw total costs. So this here is TVC, total variable costs. So total costs at any quantity are simply total variable costs plus fixed costs. So it's just taking this curve here, copying it, and shifting it up. Now, in the old days, I had to draw this by hand. Now watch me fail in the digital age. Oh, I already see. I tried this last night. Okay, right click. No. We can do it. Okay, here we go. Let's try this. Now, whatever. Let's go analog. So the point where the total cost curve is going to be at this point is exactly fixed costs above the point where the total variable costs are, so 20 units above. So the curve should start here, right, at 20, and then the inflection point should be exactly $20 above this point because total fixed costs are $20. So the first part of this curve should look something like this. And again, you're going to say, Max, that doesn't look parallel, bless you, but it is. Why is it? Just huge hands. All right. So spread it like that, right? And then compared to this, it's exactly the same distance. It's just, again, it's steeper down here, so they look closer together than up there. Now, I know one more point. Pick any point that is $20 above the total variable cost curve and fit a U-shaped thing through here. So this is going to be total cost. Somewhat beautiful, not fully beautiful. But if you had to draw this in stylized fashion, the way I do it in my notes is I label my graphs nicely, and then I draw my total variable cost curve like this. And then if fixed costs are constant here somewhere, I figure out where my horizontal line is at the inflection point, take my fingers, same distance above the inflection point, start here where fixed cost intersects, guesstimate here, then pick another point up here somewhere, fixed cost apart, and then approximate. Right? So this here is fixed cost, total variable cost, total cost here. That would have been funny. Okay. Practice drawing this. This is really hard. All right? What's even harder is taking this picture and trying to get to average variable, marginal, and average total cost. It's a huge pain in the neck. So let's get right to it. Are you ready for it? Yeah, you are. Okay. I'm going to use, I'm sorry for the online people who are sitting at home with some virus, but I'm going to use the Blackboard because I haven't figured out how to use a digital shoelace. All right? So what I'm going to do on the Blackboard here is I'm simply going to draw, again, the two cost curves I'm going to care about ultimately. It's going to be my total variable cost, and then figure out some fixed cost amount. Here we go. And then by the same amount up here. Again, this is correct, right? They look closer together here. They look closer together here, but I'm not cheating with the distance of my fingers here. They're roughly the same distance apart everywhere. Now, the first thing I'm going to want to figure out, because it's easy, is average variable cost. Well, what is average variable cost? Average variable cost is variable cost over output. Right? So at any level of output, what can I do? Well, at any level of output, I can figure out what total variable cost is by simply reading it off this fancy graph. Right? So if this is a point on my total variable cost curve, then this here we could call output level 1. And off the y-axis, I can read off variable cost 1. Right? So for producing Q1 units, I would pay VC $1 in variable costs and labor costs. Well, Max, I knew that, right? But you're not asking me about total variable costs. You're asking me about variable costs per unit of output. Well, that's generally variable cost divided by output. That, can I translate that into rise over run? Yes, right? So it's variable cost. So it's the difference between the intercept 0 and wherever the variable cost point is at that quantity. That's rise over run, right? Run is the number of units I'm producing. So what is average variable cost going to be? It's going to be VC1 over Q1. VC1 over Q1 is simply going to be the slope of the line from the origin connecting to that point on the total variable cost curve. Why is that? Well, let's draw that line for a second. Okay, this is my line. What's the slope of this line? The slope of this line is rise, right, from 0 to VC1 over run, from 0 to Q1. So the slope of the line connecting the origin to the total variable cost curve, that's average variable cost. This is not just true at the inflection point. This is obviously true at any point on this particular total variable cost curve. So let's play this annoying game where Max sort of takes his left thumb. I'm pinning down the shoelace at the origin, and we're going to watch what's happening to my neon, the slope of the neon shoelace as I go along the total variable cost curve. Let's do that again, right? It's falling. My arm's probably blocking it. Let's try that again from here so the other side of the class can see. That's probably non-blocking everybody. But, right? I don't know how to do this. But does everybody see? So my right thumb is tracing the total variable cost curve, right? It starts falling until we're here, right? If I expand it the ray from the origin, again, it's going to be the point where the line from the origin is tangent to the total variable cost curve. So there's some point here on the total variable cost curve. It goes from falling right here, this point, to increasing. So falling, falling, falling to increasing again. So here, ABC goes from decreasing to increasing. Point A. How do you think I'm going to get average total cost? Come come on, Max. It's 11:58 on a Thursday, week 6. Please just tell us. All right? Okay, fair enough. If average variable cost is the slope of the line connecting the origin to any point on the total variable cost curve, then average total cost is going to be the slope of the line connecting the origin to any point on the total cost curve. Thank you. One person answered. That's a better ratio than last year. So the point is made in exactly the same way I just made the point on the variable cost curve. So I'm going to take a bunch of stuff off here. Okay, what's average total cost at any point? Again, let's take that inflection point. That's a useful way to think about it, right? At Q1 right here, total cost, meaning the sum of variable cost and fixed cost, is this number TC1 here, right? So average total cost is total cost over quantity. So average total cost is going to be TC1 over Q1. Again, pick that point on the total cost curve, connect it to the origin, and I have a line. The slope of the line is rise, 0 to TC1, so TC1 minus 0, over run, which is Q1 minus 0. So the slope of the line connecting the origin to the total cost curve is going to be average total cost. So if we do that, right, it sort of starts at infinity, and then what happens to it? Falling, 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 falling. Right here, it starts increasing again. All right, let's do this again. Falling, falling. Don't watch my thumb. All right, for those of you focusing on my thumb, don't. Focus on the slope of the line. Dropping, 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 dropping. Tangent, right here. So let's remember that point. And then it goes to increasing. One more time, because it's so much fun. Falling, 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 falling. Tangent, and goes increasing again. So there's a point here, B, where average total cost goes from falling to increasing. And that happens to be, let's see, I can tell whether this is a good year when I can actually draw these lines in one go. Oh, good one. Let's try another one. That's never happened in 11 years. All right? Here's the line from the origin that's tangent to the total variable cost curve. Here's the line from the origin that's tangent to the total cost curve. So quantity A here, that's going to be the quantity where average variable cost goes from dropping to increasing. Quantity B here is the quantity where average total cost goes from being decreasing to being increasing. All right, we're almost done. There's one more thing we need to do. And that one more thing is the thing that really rules them all. It's marginal cost. Marginal cost may be the single most important thing in producer theory. So what is marginal cost? Here's where if you had a little bit of calculus really helps a lot, right? But it's not necessary for understanding, but it helps. So marginal cost is the change in total cost due to a change in quantity. That, to those of you who have taken calculus, is simply the first partial derivative of the total cost curve with respect to quantity. It's the slope of the total cost curve. For those of you who haven't taken calculus, or for those of you who have taken calculus and don't remember any of it, which also happens, let's think about that, right? Marginal cost is simply the change, not ATC, it's the change, nice delta max, here we go, change in total cost due to a change in quantity. All right, now the way to think about this is as follows. I'm engineering things here, so maybe I should start my next career in engineering. A lot of famous economists started as physicists, so why not let's take it one step further and have a bunch of mediocre economists like myself become engineers and see if we do better there. I'm joking. Okay, are you ready for this? This is high science. Nice pink thing, okay? Neon. So what I'm going to do here is I'm going to argue that the length of this thing here is exactly 1 unit, all right? So the length here, this straight line, is exactly 1 unit. So if I go to my total cost curve, which I'm just going to draw in a little bit because I erased it with my thumb here, if I put this pink thing right here, this connects total cost at 1 unit, at 0 units of output, to total cost at 1 unit of output, right? So if we're thinking about total cost at 0 versus total cost, let this be, sorry, bless you, let me be clear. Try this again. Thank you. So 1 unit apart, okay? I'm going to go up 1 unit from 0, and I'm going to go up here. So this here is total cost at 0 units. This here is total cost at 1 unit of production. So the change in total cost is going from this level to this level. That's the change in total cost. And the change in output is going from 0 units to 1 unit. Right? So marginal cost is the change in total cost over the change in output. The change in total cost is this. The change in output is this. I've got a rise. I've got a run. Right? So marginal cost is going to be the slope of the line that connects any 2 points on this particular curve. So let's do that for the next unit here. So if we move 1 unit further, okay, so 1 unit further out. So here again, we've got plus 1 unit of output. What's the total cost now? This is my total cost. So I'm going from 1 unit of output to 2 units of output, so that's run. Rise is, I started at this amount of total cost rises by this much. So the change in cost is simply the distance between these two right here. The change in output is simply the length of this line, which is 1 by definition. So marginal cost, again here, is going to be the slope of the line connecting these 2 points. So marginal cost, you can do this anywhere, is start at a point, add 1 unit of output, and look how total cost changes. So marginal cost is simply the slope of the line connecting any 2 points on the total cost curve.